Or pink it, yeah. All right, this is page 81.
Okay.
He's using your word shirt.
We're looking at central angles today, okay? The way these notes are laid out is the top of it reminds you of the example and the definition, and then it goes into practice problems. Today's lesson will involve subtracting, adding, and recognizing vertical angles. Remember vertical angles? Any two lines that cross, vertical angles are created, and vertical angles are congruent. They're equal. Okay. This unit is a challenging unit because it forces you to be a problem solver. Remember with the right triangles, like every picture was pretty much the same, right? You labeled the picture, you figured out which trig function you're using, and then you set it up and you solved. Okay, with circles, you're going to have to be a problem solver because no two questions are alike. Because sometimes it'll have a radius, sometimes it'll have a diameter, sometimes it'll have a secant, a tangent. See where I'm going? Okay, so circle problems are challenging because they force you to be a problem solver. This goes back to that thing that I said to y'all, not day one because we played games that day, but like day two. When I said my goal was to teach you geometry, but it was also to teach you how to be organized, and then how to, bless you, how to be a problem solver. The importance of high school math is not necessarily the geometry itself. It's that if I teach you some stuff, can you pull things that you know and be like a puzzle? It's like a puzzle. No clue. All right, let's refresh your memory. Central angles are angles where the vertex is the center of the circle. Which means if the vertex is the center, the two sides of the angle are actually each a radius. So here two sides are radii. How many degrees are in every circle, no matter the size? 360. No matter the size of the circle, there's 360 degrees in it. And that's because it's not about the size of the circle, it's about the rotation. So if you think of like a skateboarder who does a 360, that means they did a full rotation, right? So every circle has 360 degrees in it. For example, if you look right here, I'm going to highlight the central angle from A to B to C is the central angle. From A to B to C. Might help. They're on the bookshelf. Files, don't distract her. Okay.
I'm distracting myself.
Well, quit.
You do that fully.
Okay. So this angle ABC is an example of a central angle. You could have also called it angle CBA, ABC or CBA. Okay, the new part is the degree of an arc. This is the new thing for today. I want you to think of a round cake and you're cutting a triangular slice out of it. You would lay the knife to the middle and then you'd come over to the side, cut another slice, or create another indentation, and then you'd slide the cake out, right? The slice, y'all with me? Like there's your slice of cake. The new part for today. If the central angle measures 84, then the measure of degrees from A to C is also 84. The central angle equals its arc. It is equal to its arc. That's the new part. That's what we're going to practice today. Right? So, here's how you read this. What is the measure of arc A to C? Since it's 2 letters, it means go the short way. And it would be 84. Right? It won't let me put a degree sign. You staying with me, Ashlyn? Riles, I really hope you're not distracting her. Hello. All right. What's the measure of arc A through D, end on C? I'm going to change colors. A through D, end on C. You'll notice that that's almost the entire circle except for the 84 part, right? So what puzzle solving strategy would I use to find it? 360 minus the chunk that it didn't cover, and you get what? 276. That's the technique for these problems. Now, we do have a new part, or not new part, we do have a helpful part. If your picture has diameters in it, diameters cut circles in half, creating 2 semicircles which measure 180 each. That's huge. So I want you right here in the very first example, I want you to write this. Look for diameters. And it's not that you're looking for diameters in just this problem. It's just now we're starting to practice, and I need you to look for diameters every time you have a problem. Okay? Because diameters cut it in half, which creates the 2 180s. And that's where that whole problem solving, it's a puzzle, piece it together, comes into play. All right, let's look at the number 1. Instead of sitting here trying to find every single one of these, because there's so many, it would be easier to just come to the picture and start labeling it what you know. I actually know that right here is 21, right? Okay, I just learned if I know a central angle, I know its arc. So if this is 21, open up, think of a flashlight, or think of the edge of the cake that your slice you're pulling out. So this is 21, this would be 21. Right? Look for diameters. I'm going to go with a highlight here. And you want to be careful highlighting on your paper when we have multiple problems because it's going to start to get messy. Now when we have just like, oh, find one thing, highlighting is more helpful. When it's something like this where there's multiple questions, the highlighting is going to get messy, so just watch me do it. Do you see any diameters? How many? There's 2 clear diameters. Focus on just one of them. There's one right there, right? I like to highlight the diameter in my mind out so I can see the semicircle. So there's a diameter, which means there's a semicircle which measures 180, and look at it.
Minus 21.
You know this chunk is 21, so that leaves this chunk which would be found by typing what in?
180.
180 minus 21. What do you get?
159.
Yep. So this is 159. Now you can see why highlighting is not helpful, because now we're going to remove it and we're going to do something else. Now, go back to it. We still had a diameter here. This side also measures 180. I know nothing about it yet, right? But if you have 2 diameters, then you have 2 straight lines, which creates vertical angles. And vertical angles are equal. So if this is 21 here, I got to take the highlighted off. If this is 21 here, then shoot down right below it. That would also be 21, which means this arc here would be 21. Now, go back to, this is a diameter. That's 180. If this is 21, then this piece from here to here would be 180 minus 21, which is 159.
I can do that. Hold on.
Okay, so the other thing with circles, and it's going to happen a lot, pretty much every single problem has multiple approaches, and they're not wrong. And there's no way for me to show all of the approaches because we would be here forever, or I might confuse somebody. So if you saw it a different way and you got all the answers right, we're going to say go with it. Just make sure you're keeping in mind they have to add up to 360. Keep in mind vertical angles are equal, so their arcs are equal. And keep in mind diameters create two 180s. Now we can answer these questions. Here we go. J to K. That's two letters, which means go the short route. So J to K is 21. If it's an arc, that means stay on the edge of the circle. If it's an angle, that means you're going somewhere in the circle. This says angle J to N to M. So J to N to M means right here. And I don't have it written down, however, I do know it's arc, so I know it. It's 159. Because that is a central angle. Okay, K to L. Short route, two letters. Shortest way from K to L would be what measure? 159. Now we got J to K to M. J to K, land on M. Two ways to do this. No, three ways. Three ways to do this. One, just add up the pieces as you trace it, right? That's one way. Works every time. Second way, say to yourself, well, I almost highlighted the whole thing. The only part I didn't highlight was 159, so I could do the whole thing, which is 360, minus the 159, then I'll get the answer. Third way, which is the way I need you to start training your mind to look because it makes life so much easier. You see a diameter in there?
Yeah.
Do you notice that the diameter runs from here to here? And it was J to K to M, so this was the only piece. So 180 plus 21 is a third way to get it. What'd you get, 201? All right, now we got M to K to L. M to K. Now, don't go this way. Watch. Red means wrong. You don't want to go M to K to L. You should know that's not right because you just overlapped your circle. We're never doing that, okay? Go in the direction that would hit that letter without the last letter before it. So we want to go M to K to L. What would be the ideal way to find that one? The fastest way. 360 minus the chunk it didn't cover would be faster, right? Tell me what you get. 360 minus 21. 339. All right, I want everyone to try number 2. Yeah, and then we'll check it. How many diameters are in number 2?
1. Oh, I see it now.
There you go. So you've got one here, and then you have the one here.
I see it.
So you do have 2 diameters. All right, you try it and then we'll check it. Penny. Penny. Be careful. Red means wrong here. Red means wrong. Please, 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 please do not try to draw your own diameter. Don't do that. Because your drawing will be arbitrary. Arbitrary means like pin the tail on the donkey, right? It's not entirely accurate. So don't try to draw your own diameter to think it's going to help you. It won't. It'll create more problems. All right, so let's look at this. There are two diameters here. You got one here. You got one here, right? And then you also have one here. Make a note. Maybe go to the top of your paper and write this. Two diameters creates vertical angles. Make a note. Go to the top of your paper. Or even, you could even make it right here since this is where it's happening. But two diameters creates vertical angles. I've run out of room, so I had to abbreviate angles. Oh. Okay. So always start with what you know and then label what you can. So here is 87, which means think of a piece of cake, go to the icing's edge. Then from here to here, T to U would also be 87. I know this arc here is 72. Be careful. Make sure it matches up with a piece of cake. Does this arc 72 have a central angle cut in the cake? Like, is there an angle created? Yes. So if you look right here, from here to here would be the piece of cake that I'm talking about. So if that's 72, then this right here is 72. With me? Okay. Now, diameters and vertical angles come in. Okay? Also, do y'all remember what a straight angle is? Yeah. Look right here in the middle. So, not only does a diameter create a semicircle that's 180, but if you have a bunch of central angles in a circle, right there, you have a straight angle. So from here to here would measure 180. So same concept. So that diameter from here to here is 180, and I'm only missing one chunk. So 180 minus 87 minus 72 is 21. Okay, if that's 21, then what's this? 21's kind of hard to write. Looks like 22i, but that was 21. Now we got to go to the other side. Do you see any vertical angles? Yeah. Find the two diameters, because the vertical angles are always between them. There's one here, and there's one here. So, which angle is in between touching the two diameters? 72. So right here would be 72, which makes this arc 72, which makes from here to here 180. So 180 minus 72 is what? 108. So right here is 108. will not let go. It did. And if that's 108, what's that? 108. Now let's answer the questions. Angle UXV. UXV. Did you get 72? Arc S to T. Arc W to V. Arc T to W. Short way. That would be this way, right? So what do you do with them? You add them up. You get 93. Arc T to V to W. All right, go to the next one. What's in this one that wasn't in the other one? And that's okay. That means you know that it measures 90, which means its arc measures what? 90. Do what? What's your question? Do what? Yeah. Okay. Remember, look for diameters. How many diameters are in this picture? There's 2, right? And because that one angle is 90, the 2 diameters is just basically cut 4 slices into that cake with the one right here. So like right here would have to measure what? 90. And what about over here? 90. And then those 2 together, whoa, right here. Those 2 together would be 90 together. Now, if this is 34, then what's this? Wait, I went inside. 34. Now, how do you get the 56? What's that come from? There you go. So from here to here has to measure 90. 90 minus 34 would tell me this is 56. And now I can start piecing together those arcs. So C to D is 90. F to D is 90 plus 34. D to C, end on F, would be 180 plus 56. So what is that? 236? Yes? All right, G to D to F. G to D, end on F, would be 360 minus 56, so 304. Let's go to the next 3, just because so we don't get caught up by the announcements. You do need to do number 4 on your own, but go to the next 3 while I have you. Don't let the algebraic expressions throw you for a loop. It's the same thing. So just go and try to find that piece, and then you just set it equal to it. So like right here, do I have any diameters?
Yes.
Remind yourself, look for diameters. We have 2 here, which really we don't even need the second one, but we have a diameter. The one that's helpful is the one that I know the arc right there. You see it?
Mm-hmm.
Y'all with me? All right, so that has to be 180. Do you have something for each of its pieces? You have something here, and you have something here, so you can set it up. So that crap plus that has to equal 180, right? You with me? Okay, or, you know they have to add up to 180, right? Use the subtraction method to subtract off what you already know, because then numbers get smaller. So if you know from here to here is 180, what's this? Okay, so what's 180 minus 26?
154.
So then this right here has to be 154, and you could set that equal and you have less work to do. It's called the subtraction method, where you know what it has to add up to, you subtract off what you already absolutely know, and then what's left, that's what it has to equal, the algebraic expression. So we would add 26. What is that, 180?
Yes.
Divide by 15.
X equals 12.
Oh, no. Now, we only did that here because it was asking for so many pieces. Now we don't do that. Yeah.
Number 1.
Soccer game. What's the score?
4-0.
That's crazy. Usually it's like 1-0.
Good afternoon, your bus changes for the day.
You got to talk to Dale.
What about the
bathroom?